Good morning. Well done to all of those of you who submitted such great graphs from Monday's work. Lots of people using rulers, setting the axes out correctly, remembering labels. Really, really good. I was very impressed with those I've seen. If you haven't done that, I'd be really keen to see yours. Please submit that via class charts. We're going to talk about scatter diagrams today, and in fact for a couple of lessons. I've attached a 2-page worksheet which ideally I'd like you to print. I know not everyone's able to print, but hopefully the majority of you will be able to. If not, you can still work from the screen. And I'm actually going to look at the first page, but not look at the top here. We're going to come back to those definitions. I'm going to look at this question here. So here I've got a set of data, and I've got two things recorded that go together. So for every car, and this is about 12 cars, I've got two things recorded. And I've got the age of the car and its current value. And data like this, that's arranged in pairs, has a rather fancy name. It's called bivariate data. It's not a word you need to worry about at the moment, but it just means we've got two things, two variables recorded about each particular car. And bivariate data is best displayed on a scatter diagram. So here a set of axes has already been drawn for us. Our horizontal axis is age in years, going from 0 to 8, and our value goes up the side on the vertical axis, and that goes from 0 to 6,000. Don't always have to start at 0, but in this case they have. So I am going to plot these points, and I'll speed up the video while I crack on with that. 5 years, £2,500. So that's one car along to 5, up to £2,500. So I have plotted that pair of values on my table. 3 years, £3,000, along to 3, up to 3,000. You get the idea, right? Give me a minute while I finish it off. Okay, so I've plotted my points, and you can see that, as you would expect, as cars are getting older, their value is dropping. Now, that doesn't give us a perfect straight line on the graph, but there's definitely a general trend there. And where we see that sort of trend on a scatter diagram, we refer to it as correlation. And when we look back at the definitions in a moment, you'll see that what we've got here is probably a moderately strong negative correlation. If the graph shows a correlation, we can draw a line of best fit. And a line of best fit is not a dot-to-dot line that goes through all the points. A line of best fit is just a line that tries to describe the rough trend. It doesn't have to go through 0, 0. In fact, line of best fits rarely do. And this one certainly isn't, because it's going to be going this way. And the thing I always try and do is I try and balance the line so I've got as many points above the line as below the line. So I don't know, I reckon it's going to be something like that. Now, drawing a line of best fit is always something you do by eye. So if I asked 3 of you to draw lines of best fit, you'd probably get 3 different lines, and it doesn't mean one of you's right and one of you's wrong, but we're always going to be estimating everything after this point, because we've probably all drawn a slightly different line of best fit. So we are asked in this question to estimate the price of a car that's 4 years old. So here's 4 years old. What I'm going to do is go up from 4 years to my line of best fit, and from there I'm going to go across to the value axis. And I'm going to make a judgment. I reckon that's about 3,200. So I reckon that that's £3,200. Now that's only an estimate because my line of best fit might have been slightly different, and I'm not asking you to do this question, but if you did, you might find you got a slightly different value. Another car is less than a year old. Why is it unreliable to estimate its value from this graph? Well, I haven't got any data for cars that are as young as 1 year old. The only data I've got starts at 2 years. So it is unreliable to make predictions outside the range of values. And that doing that is something called extrapolation. So extrapolation is bad news. What we did up here is called interpolation. That's making predictions within the range of values we've got plotted, and interpolation is good news. I just realised that I missed off part C. So we've said that we've got a relatively strong negative correlation. So what that means is, as cars get older, their value drops. So the answer to part B was negative correlation. Part C was, what does that actually mean? Well, that means that as the cars get older, their value drops. Surprise, surprise. Let's go up to the top of the chart, the worksheet now. So we've got here some examples of what correlation looks like. So you've got an uphill line here, which shows a moderate positive correlation. So if you see a trend that's going up, that's positive correlation, and that's where whatever it is you're plotting, as one thing's getting bigger, the other thing's getting bigger as well. We got a negative correlation. This is an example of a really strong negative correlation. With negative correlation, as this thing gets bigger, this thing, whatever it is, gets smaller. Here we've got a much weaker positive correlation, so there's still a general trend there, but it's not quite as strong. And sometimes you plot things on a scatter diagram, there's no relation at all. There's no relation between what those two things are. So we've got the idea of correlation being an indication from a graph that the two things that we are plotted are related. Now this thing here about correlation and causation I'm going to come to in just a moment. All right. Here you've also got a reminder about don't extrapolate, don't try and make predictions either below or above the biggest value or the smallest value that you've got plotted on your graph. So I'd like you to attempt the questions on the second page. So if you're able to print, that's all very well. If you're not, you would just have to draw these axes out on paper or in your book, and I'll reattach that sheet of squared paper for those of you without your books at home. So you've got to plot the values in the chart. Remember, this is one cross. In this case, we're talking about the marks two judges give to a particular dancing competitors. So the first cross I'm going to go along to 7.5 and up to 8, so that would go there. I'll leave you to do the rest. And you've got some questions here to talk about, including the drawing of a line of best fit. For question 3, you haven't got to draw any graphs at all, but you've just got to predict, would you see a link, would you see a correlation between those things? And so your answer will be positive correlation, negative correlation, or no correlation. And question 4 is really tricky. Question 4 highlights one of the other things that's mentioned on that first page. This point here doesn't fit the trend, so we call that point an outlier. An outlier is just a freak value. We don't know, it might have been something odd going on. This is about temperature and ice cream sold. So here we had a cold day where there were lots of ice cream sold. Maybe there was a special event on. So you often get outliers, and so that's what they're talking about there. They ask you to estimate the gradient of the line. And I don't know if you got as far as doing gradient when you were doing algebra. I suspect not. So let me tell you this. The gradient of a line is how much it goes up, how much it goes up. For every 1 unit you go along, which in this case is 1 degree. So how much the line goes up when you go along 1 degree C. And I'll be interested to see how well you cope with that one. And I've told you what the definition of the gradient is, so you might like to have a go at interpreting that question. Now, I don't need you to have a go at question 4, but some of you might want to. And if you do, I'd like you to attach your answer to class charts. And you'll note that I've attached answers to questions 2 and 3, but I haven't attached answers to question 4. So I don't expect you to do question 4, but for some of you, I know you would like a challenge, and I'd be interested to see how you get on with that. So you've got question 2 and question 3 to do, and some of you question 4, and you're going to submit that one on class charts if you have a go at it. So just returning to this little set of notes, this is a really good little summary of scatter diagrams. So we've talked about correlation, we've talked about positive and negative correlation. We've mentioned outliers. We've talked about extrapolating. We've talked about what correlation actually means. So if you've got a positive correlation, it means that as one thing's getting bigger, the other's getting bigger, and the reverse is true for negative correlation. But what about this correlation and causation? Well, can I give you a couple of examples by way of explanation? Let's pretend that I went to Willicombe every day for 30 days in the summer holidays, okay? And every day I went to one of the beach shops and I asked them, how much sun cream have you sold and how many sunglasses have you sold? So each day I'd have 2 values. I'd have the number of sunglasses sold and the amount of sun cream sold. Bivariate data, I could plot that on a scatter diagram. Each day would give me a cross. Now I'm pretty sure that you would find that days on which lots of sunglasses were sold, they also would sell lots of sun cream. And days where you didn't sell many sunglasses, you probably wouldn't sell much sun cream either, and there'd be days in the middle. So I reckon that that would give me a pretty clear positive correlation. So I think that there's clearly a correlation between sun cream and sunglasses. There's a link there. The two are related. So I think in that first example, I have a correlation. Does that mean, though, that buying sunglasses is some way causing people to buy sun cream? Or buying sun cream is somehow causing people to buy sunglasses? If you buy sun cream, are you forced to buy sunglasses? And I don't believe that's true. I don't believe that one is causing the other. I don't believe that lots of sales of sunglasses are causing lots of sales of sun cream. I think there's something else involved. I think the temperature is probably the thing that's causing both the sales of sun cream and the sales of sunglasses, or rather perhaps the amount of sunshine. So it's important to understand that a correlation, there's definitely a correlation between sun cream and sunglasses, doesn't mean causation. And can I give you another slightly more sort of serious example? If I looked at data recorded for lots and lots of different countries, and I looked at infant mortality, that's the number of babies per 100 that die within the first year of life. And I also looked at how many mobile phones were owned per 100 people. I'm pretty sure that countries like our own country, where lots of people have mobile phones, we have very low infant mortality, fortunately. Very few babies die very young. I expect that sadly, countries where perhaps mobile phone ownership isn't as strong, perhaps because they haven't got the same infrastructure we've got, maybe also be countries where you've got quite a high infant mortality. And there's going to be some countries in the middle. So I'm pretty sure that I would get a correlation between mobile phone ownership and infant mortality. But does that mean that owning mobile phones means babies are more likely to die? Is that causation? And again, I don't think it is. I don't think that one is causing the other. there's something else involved in this situation, isn't it? And it's almost certainly going to be related to poverty and the way that a country is less developed or more developed. So it's important that we can recognize correlation from a scatter diagram, be it positive or negative, but it's very important that we don't automatically assume that one is causing the other. We will next week, though, be looking at some real life data, and in some situations we will see correlations that are also causations. Take care.